So here's the last thing we did, you guys, is this question, and we got it done, and we got D as in dog. And so now let me scroll through and find the next. This one, number 12 is not BC only. So remember, we're only doing the BC problems. Which of the following logistic? Yeah, this one is BC only. But how can I include both? Oh, I have an idea. There. Okay, I need the Word document open so that people can see what I'm writing on the video. But there's that one. I don't even know if you need 2 minutes on this, so let me give you just like 1.5 to see if you remember how logistic equations work. But here's a few seconds. Ready, set, go. I'm gonna turn some lights on. No, I'm gonna open some blinds. Yeah, you want paper as well? I mean, I don't know that you need it today, but or like for this problem. But I have some if you want it. Okay, I think 1.5 minutes even was too long. This one I thought was not that bad because remember logistic equations. I mean, they always look like. Oh, I got it right over here. They always look like this, ooh, like that, with some sort of carrying capacity. Or I guess depending on the initial condition, they could look the other way, but like they could look like that maybe. But in this case, the initial condition was that it starts at 100, and then the carrying capacity is this 500. Remember, you could tell in a couple ways. You could either tell by like whatever the y is being divided by, or you could like re-multiply that 500 back into it. And then it would be this number that tells you the carrying capacity. But either way, you didn't have to look super hard at this one. It should have been D as in dog. Okay. Absolute minimum of that is not BC only. Graph of G prime, G0, G of 3. Not BC only. This one is BC only. That's a little bit of a hint. So 16, try that one. And for this one, you might need more than 2 minutes. So here's 2.5. I'll be right back. Hint is that that's faster if you didn't test before. That's it. That's it. that's ideally how long you spend on this problem. But this looks like it might be pretty involved, so keep working if you're still working, so that I can catch up to you guys. Okay, or you're still working. Okay, keep working, keep working. Here's some hints if you need them on the board. Hey, James. Okay, even if you're still working, let me say some stuff. So, first of all, when I saw this right away, I said, oh, nice, they factored it for me. This means I can use partial fraction decomposition. So that's the one where you say a over the first factor plus b over the second factor should equal this, the original fraction. And then remember, you cross multiply. And once you do, that should get you back to the original numerator. So a times factor plus b times factor equals original numerator. And then you were supposed to choose some strategic x's. The x equals 1 is maybe pretty obvious, but x equals 5/3, you have to kind of solve this for 0. But if you add 5 and divide by 3 on this first factor, that's how you get the 5/3. Plug that into every x and solve the result, and boop, 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 you should get b equals -9. Oh shoot, I messed up down here later. But I'll mess with that later. And then if you choose x equals 1 and you solve the result, you should get that a equals -2. So far, so good. Okay. Then you go back and you replace your integral with those numbers that you got. So it should be -2 over 1 minus x plus -9. So let me just actually write this as -9 over 3x minus 5. And then I'm glad we went over this yesterday because both of these are like, you should not skip the u substitution unless you keep track that this will be negative and this will be divided by 3. You should not skip the u substitution. So again, if I show every single step, I would maybe take out the -2. I would separate these. I would, if I was a student, probably not skip the u substitution. And I would say u equals 1 minus x, and then du equals -dx. And that's why I'm saying don't skip it, because then when you solve for dx, you get -du equals dx. So you'll get a next negative in front of this. So basically, this is going to turn into +2 square root, or integral 1 over u du. And then well, we do that in green or something. This u substitution would be u equals 3x minus 5. So du would be 3 dx. So dx would be 1/3 du. So basically, this 9 will be also multiplied by that 1/3 from the du and become -3. That looks like a b, but that's a u. Although maybe I should have used a different letter. But anyway, you get these two, and your final answer should be 2 natural log of 1 minus x minus 3. Well, I should have done that in green. natural log of 3x minus 5 plus c. Is that one of the answers? Positive 2 minus 3, shoot. Oh, it is, it's A. A is an apple, look. A is an apple. There it is. Okay, there was a lot to mess up here. First, you had to know to use partial fractions. Then you had to know what x's to plug in. Then you had to remember the negative du and the du over 3. And then you had to get the antiderivatives correct. So many chances to mess up, but if you did it right, you should have gotten A. Let me make sure I'm not lying to you and mess the negative or something. Remember, this is page 30. Don't forget that number. What problem was it? 16. Nice. Is A as an apple? Okay, good. We didn't miss anything. All right, page 30. Spherical snowball melting in such a way, what rate? No, that's related rates. Not BC only. If f of x equals that, f prime, that's fundamental theorem, not BC only. So for the tangent line to the polar curve, yes, BC only. See how much you remember about slope of tangent line of a polar curve? Great luck, 2.5 minutes. Okay, this one has been months since you've seen it, and depending on how much homework you did, you might have not practiced this very much. But if you see slope of a tangent line, or slope of anything, that's always rise over run, so you should be thinking change in y over change in x. And you have to remember for polar curves, y is always equal to r times sine, and x is always equal to r times cosine. And in this case, r is equal to this whole function. R is that whole function. And so when I take dy dx, that would be the derivative of y over the derivative of x. And even that itself is a whole problem because that's a product rule. So first times derivative of the second for y plus second times derivative of the first. over, same thing for the bottom, first times derivative of the second plus second times derivative of the first. Then you needed to plug in pi for theta, and usually all the ones I've seen for these like slope ones or whatever for polar functions, they usually give you a nice number like pi or pi over 2 or something, which is at least nice. And that's the case here. You plug in pi, you get 0 for all the sines, which is nice, and the cosines would all be -1. You get 2 pi squared over 4 pi, which ends up being pi over 2, which is answer B as in boy. I was doing the problem, so I didn't check if you remembered any of this, but how did you do? Did you remember? I'm impressed if you did. Because yeah, that's something we obviously you haven't practiced in a long time. So good job if you remembered, and if not, then like you just need to see it one or two more times, and you'll remember in 2 weeks. All right, next BC only one. Twice differentiable, which of following is true, G prime, G double prime, not BC. This, with the Earth, I think this will be long division. Right? And then it won't be BC only. I don't think this is BC only, but it's still a good problem to do. You want to do this integral real quick? Yeah, all right, I think you should. Again, I don't think it'll be a BC only technique, but maybe after the long division. All right, try that one. Here's 2 minutes. Technically, you're supposed to only use 2 minutes per. You might need one. Okay. Yeah, depending on your long division, this may have taken you a long time or a little time. Because after the long division, then it's 3 really easy antiderivatives. But you have to know, like, why did I know this was long division? It's because the smaller degree was on the bottom. So usually that's a big hint. Because basically, if you're thinking, oh, I might be U substitution or something like that, or maybe I should split it up or something, then you won't get very far, and you can try that yourself, but you won't get very far. So usually, if it's like a whole big polynomial over a whole big polynomial with a smaller degree on the bottom, you have to do long division. Long division is the one where you look at the leading term of the numerator and denominator, and you say, what do I need to multiply by? So for the 6x squared, you need to multiply by 6x. You multiply the denominator by that, you get 6x squared minus 12x. You subtract, and then you repeat. Anyway, if you need a reminder on long division, I'm here, but I don't know if now's the time. But you do some long division, boop, 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 boop. You get a quotient of 6x plus 8 and a remainder of minus 9. And then you can take, once you do the long division, it's all just straight up anti-differentiation. So antiderivative of 6x is 3x squared. 8 is 8x squared, and negative 9 over x minus 2. That one you can use it, or skip the u substitution because the derivative of x minus 2 is 1. So you skip it, and you get 9 natural log of 2 of x minus 2, which is a as in apple. Too fast, or you're fine with it? Nice, you guys. Okay. Next BC only one is that one for sure. You guys try that. Hey, Adam. Here's 2 minutes. Oh, before I forget, let me tell you that I've been forgetting to tell you, I wrote it on the board, but you have a digital version of this test if you want to do some at home, and 3 other tests. This one's the 2018 one if you're trying to go back over the questions that we've done. It's on AP Classroom. You have access to it on your computer at any time, and you can check your answers and everything. So before I forget to say that, there it is. But now, see if you can answer that. Start the timer. Hey, Sawyer. Okay, that one you may not need 2 minutes, but you may have needed the 2 minutes because this is so new. You haven't built up an intuition. But what did you say about? Did you see what the answer was? Okay. Well, did you get it right or no? Good job if you did. Okay, this one, if you had no idea what to even do, you just saw a bunch of letters in there, I can tell you that my thinking was the following. When I saw this, I was like, oh, 1 over natural log. Natural log is not a very fast growing thing. So in my heart, I was like, this has to diverge. Like, if this grows fast, then it should converge. If it doesn't, if it grows slowly, like natural log, then it should diverge. So I looked at these, and then I was like, oh, they made it even easier than I thought, because it can't converge comparing it to 1 over n, because 1 over n diverges, and it can't diverge comparing to both. It can't diverge compared to n squared, because n squared converges. So it has to be A or C. And, no, sorry, it has to be B or C. That's the way that converges. This one converges, this one diverges, so it couldn't be opposites. Like, like I was saying. And then I thought about it and I was like, wait, comparison with 1 over n, does that work? And that's why I drew these pair functions, because it does indeed work. Like if natural log grows super, super slowly and at like 1 over x or like 1 over n grows in a normal, like at a normal pace. In other words, x gets bigger than natural log. So 1 over x is smaller than 1 over natural log of x plus 1, whatever. So it has to diverge with by comparison with 1 over n, the harmonic series. So C as in cat. I know I just kind of waved my hands a lot, but eventually, like if you see enough of these, you kind of start building an idea of how to do this. But like I said, I looked at that and I was like, natural log grows really, really slowly. If it was an n factorial, if it was an n squared, if it was an n to the third, or something like that, then I'd be like, oh, that's growing fast enough to converge. But natural log is like one of the slowest growing functions. So 1 over natural log doesn't get small enough to converge. It was my thinking. All right. What time is it? 32? Oh, we have lots of time. Length of curve from that. Oh, that is BC only. Maybe you don't remember this, but the length of a curve. This is easy if you remember the formula. It's hard if you don't. But okay, here's the I don't want to give it the whole thing away, but I'll just write a hint. In case you don't remember the formula, maybe that's enough.
I remember like the idea of what it's doing is like making the curve a bunch of little straight lines and then adding those together. But I don't remember what the formula for that looks like.
Basically, there's a distance formula.
Yeah.
And then you remember what the trick is. Then if you, I had a fun time watching your faces go through all the things that you've learned. But anyway, the trick is that if you now divide by the independent variable, basically this x minus 1 squared, oh, I guess I already did it for the thing. And obviously multiply by it so that you don't change the value of the thing. Then you get like basically 1 plus like slope times change in x. So the formula is 1 plus f prime of x squared dx. So if you remembered this formula, great job. If you didn't remember the formula, then remember the way to derive it, like to get it, is to start with the distance formula, divide by the independent variable, whether that's t or in this case it's x. Divide by it and multiply by it, and then you kind of see that this will be 1 plus slope squared times change in x. So 1 plus f prime squared times dx. And that is d as in dog, right?
Yes.
Cool.
Yes.
36. All right, we got time for like 1 or 2 more. I don't know that I needed all this space, so let me get rid of this. Make it small. Put it over here.
Nice.
Maclaurin series for sure is us. Here's 2 minutes. Might have to be that. I'm not even done with this one. Oh, you know, it might have been easier to just get the 3. I don't know. Okay. Let me finish and then we'll see what I get. So 0 would be cubed over 1 times 3 plus, no, minus 1 would be yikes. What I miss? What time is it? 40. I missed something, but I don't see it. I'm trying to rush to see if I can find it. But here's up to my mistake. I can tell you what I was doing. I would say, okay, if f prime is sine of x squared, well, I know the Maclaurin series for sine of x is up there, is this. Right there. Oh, people in the video didn't see what I just pointed out. It's this. That means that, oh, and if I distribute this like this times that would be 4n plus 2. So there's f prime, which means that f of x would be the antiderivative of that. And the antiderivative of that would be add 1 to the power and divide by the new power, which gives me this. And then I don't see what I did wrong. Like, why is that not one of the options? Like, when I plug in 0, 1, and 2, I should get, let's check again, x to the 3 over 1 factorial times 3 factorial. Yeah, I don't see what I did wrong. Oh, you know what might have been easier? Oh, I see another way to do it. That might have been easier. No, maybe not. What did I do wrong? Yeah, do you see it?
I don't think so, but when you add 1 to the exponent, can you just add 1 or do you have to do the 4 times
N plus 1. No, you should just be able to add 1 straight up at the end of it. I don't see what I did wrong. What's the answer?
D.
30, 73. Okay, remember this is 24. Answer is D as in dog.
D.
This one, which is very close to mine, but I don't see what I did wrong. Why is it not 3 factorial, man? I'm off by 1 factorial. Why is it? Oh, wait. Okay. All right, I think I didn't mess anything up. Well, let me see. If I plug in 0, I get 1 times 3 on the bottom. Boom, this term is right. The 7 term, if I plug in 1, I get 7 up here. 3 factorial and 7. Okay, I didn't mess anything up. Well, I messed up just at the end. But if I plug in 1, look at 2 times 1 plus 1 is 3 factorial times the 7, which is the 42. And then if I plug in 2 into this, I get 5 factorial times 11. Okay, so it was just a small mistake. Sorry. But we actually, I mean, everything was good. Everything was right. I just plugged in my number wrong. So it should have been 5 factorial times 11, which is the 1320. So we actually got it right. I don't know how much sense that made, but you guys got to go to class. So I can re-summarize this tomorrow. But I was just so focused on what I do wrong. It hurt my pride that I got it wrong, but turns out I didn't. Okay, tomorrow we'll do more of this, and we're almost done. I mean, there's only 30 questions in the first part, and then 15 questions in the second part. So I think we'll finish this by the end of the week.